5 saying?
How many valence electrons are in a per-sulfate ion SO5 -2?
Valence electrons per sulfate? Yeah? That's it? Okay. All right, so how do you think you detect this problem? How many valence electrons are in the outermost energy level of per sulfate? Anybody have any idea how I kind of go after that one? Oh, sure.
Isn't it the column that like the elements are?
Okay, so we know that sulfur and oxygen, are they in the same column?
Yeah.
They're both in the same column. So sulfur is in column 6 and oxygen is in column 6. All right, so kind of helps. Kind of helps. What do we do after that? So that would give me 12? Chris, 12?
No, you gotta do it for each element that's there. So for oxygen, you have to do 6 times
6 times 5?
5. Yeah.
5 times 6.
5 times 6.
All right.
Plus 2.
5 times 6. Why are we multiplying by 6? Because it's in group 6. And the group 6 means I have 6 valence. All right, so then I have 30 there. Okay, now what about sulfur?
It's just 1. I mean, it's 6 because there's 1.
Okay, so again, group 6 means 6 valence. All right, times 1 equals 6. Okay, so we're getting warmer, and we got this guy here. How about this? Are you doing anything with that?
Yep.
What do we do with that? You think?
Yeah,
Add 2? All right, so what do we have?
3.
Yeah? Okay, what other questions did you have? Spencer, I don't know what 20 is, so you need to talk to me.
Why does atomic radius decrease across the year?
Oh, all right. So why does atomic radius decrease? All right, across a period. All right. You could do some very quick answers. All right. Okay, grab his side.
I would, because when you move across the period, you're adding protons.
That's it. You're adding protons. All right. There is another answer you could have. More protons is acceptable as you move across. All right. What else? Anybody have anything else? Yeah?
Aren't the electrons pulled closer to the nucleus?
Okay, electrons hold closer to the nucleus because of more protons. All right, pull closer, okay, because of more protons. Anything else? Anything else? What happens to shielding as you go across? Does it increase or decrease? Shielding. Anybody know anything about shielding? Like layers. So like, say you're like, we're going to get into it more detail today, which is fine. But like as you go out, you have your nucleus here, which is attracting the electrons. Then you have the orbits, right? The more orbits you have, you're going to have more or less shielding from the protons. What do you think? The more orbits you have, would it shield the pull on the protons, or would it decrease the shielding? The more orbits you have. So like this. So if I have a nucleus here, and I have my 1s, 2s, 2p, All right, guys making that up. All right, what happens as you add more layers? Is it easier or harder to get to the middle? It's harder to get to the middle. So that means your shielding effect is going to do what? Increase or decrease as I add more layers? Okay. All right, very good. All right, so that's the other thing you could have put in that answer. All right, other questions? Yep.
Number 18.
18, don't know what it is, but you can go ahead and tell me what it is.
Which element has the highest electronegativity?
Fluorine.
That was one of the choices.
What are the other? The one closest to fluorine. The one closest to fluorine. What are the choices? The one closest to phosphorus. And don't forget, or excuse me, the one closest to fluorine. Don't forget that as you go up and to the right, so hence that line, electronegativity increases. But everything's based off of F. And we'll go over that. Not like you're expert on it today. It's a good little quick little thing. Alright? Alright? Yeah?
9.
What's 9?
In a hydrogen atom, which transition produces a photon with the highest energy?
Ooh, now I know that was a hard question. You want to know why I know that was a hard question? Tom came and asked me about that. Alright, Tom came and asked me, so it must have been a hard question. Alright, so Tom, tell me if I'm right. So if I have my hydrogen atom here, alright, I'm going to have sublevels, and here they are. Okay? N equals 1. Alright, here's N equals 2. Okay, now watch what happens here. 3, 4, 5, and then closer, that's as close as I can get, and then 7. All right, so which one would have the biggest jump? What happens as they go out? They get tighter together, so which one's going to have the biggest jump then? There you go. Okay, so this would be your biggest jump. Okay? All right, other questions? Yep.
Number 3.
Number 3. I don't know what it is, but you can tell me.
Which pair of species is the difference in radii the greatest?
Okay. All right. So what are the ones that we have?
Lithium and fluorine. And then sinus.
Fluoride.
Fluoride, yeah. And then lithium and oxygen.
Okay. Oh, so
Even
what's?
the first
So negative floor.
Oh, this is.
Negative.
Okay. All right. And then what?
And then lithium plus and oxygen minus 2 minus.
Okay.
And then lithium plus fluorine minus 2.
Okay.
And oxygen 2 minus fluorine minus.
Fluorine minus. That's it.
And then none of these.
Oh, okay. All right. So the question is, which ones are closest in size, or which ones are the same?
Difference in radii the greatest.
The difference in radii the greatest. Okay. All right. So the first thing you need to know is anytime that I gain electrons, all right, anytime I gain electrons, I'm getting bigger. Gain electrons, I get bigger. All right. It's just like eating a bunch of chocolate chip cookies. The more chocolate chip cookies you eat, the bigger you're going to get. Trust me. All right. Now, so this is gaining electrons. This is gaining electrons, gaining electrons, gaining electrons. So these guys are all getting bigger.
So,
All right.
so like something minus should be bigger than.
All right. Hold on. Hold on. You're moving ahead too fast now. All right. Now, if I lose, all right, I get smaller. All right. Why? I have now more protons than electrons. So I lose, I get smaller. But you have to understand where they start. All right. So if you're in the second row, N equals 2. I would start with lithium. Lithium would be my biggest element, right? So Li's here. And as I went to the right, we know that they're getting smaller. So this is like going to be fluorine originally right there. Lithium fluorine. Now, if I take off an electron, it's not going to shrink massively, but it is going to shrink. And I'm going to do this, I don't have the exact amount, but Li plus might be like that. So it shrunk a little bit. And if F gains 1, it's going to probably about double in size, but still not going to be exactly the same. You got to understand, both of them are going to be like what element? Li plus is like what? Is pseudo-electronic with, or has the same electron configuration as what? Lithium plus is going to be helium. This guy is going to be neon. All right, so there's a big difference between helium and neon. All right, there's going to be a big difference between those two. Okay, and then O2, here's the deal. If I gain more electrons, 2, where this gaining 1, the one that gains 2 is going to be bigger than the one that gained 1. So here's oxygen 2 minus, O2 minus, and here's F minus. So that's kind of your rule. So the more that you gain, the bigger you're going to be, because there's going to be more electrons than protons. So taking in all that into account, what do you think the answer is? Or anybody, what do you guys think the answer is? Which one? Lithium and fluoride would be the closest. Why? This guy didn't change that much. This guy came up to be about matching that size. I mean, it's not not to scale by any means. But if lithium doesn't change, all right, you're going to have the same kind of size when you go across as the F when it gains an electron. That's kind of how it is. O2 minus and F definitely can't be, right? These can't be. Li plus, what's that? Question?
They're saying like A or C.
What's that? Oh, I don't know. A. Li plus, look it. Li plus is going to get really small. This is going to get bigger. This gets smaller, and that gets bigger.
Which is the difference in the radii and
The greatest. Oh, this one's going to be the most similar. Sorry, that's the most similar. So the greatest is going to be Li plus and F minus. Sorry. No, actually, no, I'm wrong too. Li plus and O2 minus. Li plus and O2 minus. Sorry. Li plus and O2 minus. So O2 minus will be the biggest. Li plus will be the smallest. All right. Sorry about that. My bad. I talk so much I confuse myself sometimes. All right.